Hi, this video is a demonstration of how the basic parameters of a 321 distance relay can be calculated to protect a transmission line. This is based on an experiment using level training equipment and the Schweitzer 321 distance protection relay. There are three objectives I'd like to cover. The first is we want to calculate reaches for Zone 1, Zone 2, and Zone 3 based on our model transmission line. The second is we want to calculate relay settings for Zone 1, Zone 2, and Zone 3. And thirdly, we want to identify where in the relay setting sheet these values would be entered so that we could program the relay. So this is the little system we're going to connect in the lab. It's a three-phase system, and we're going to protect a three-phase transmission line using a Schweitzer 321 distance relay. So the equipment that we're going to use is our circuit breaker control box. So this is to simulate the 3-pole high voltage circuit breaker. We have a level transmission line module, and we can see the schematic down below of the three-phase transmission line and its values. We also have a lamp load that we're going to connect to simulate resistive load on the system. We have our current transformers, so we're going to be stepping the current up from 2 amps to 5 amps. We have our potential transformers. We're stepping the voltage down from 208 to 120 volts. And finally, we have our Schweitzer 321 relay, and we have the jacks coming out that we can plug into in order to inject current and voltage into the 321 relay. So looking at the single line diagram, we can see we want to set up our 3 zones of protection. So looking at up top, we can see that the CT ratio is 400 and the PT ratio we're setting at 1732. So in reality, the CT ratio is actually 0.4 and the PT ratio is 1.732, but we scaled these up by a factor of 1000 just to get better resolution in our 321 relay for our metered values. Looking at the transmission line, the total impedance is 49.3 at 72.3 degrees. So this is the total length of our line, and this is a faultable transmission line. So there's access points where we can actually insert some wires to create a short circuit to simulate a fault. So we have 2 faults that we can simulate, one at F1 and one at F2. We have our 3-phase Y-connected load, which is 100 watt, 120 volt lamps. So looking at the primary protection for the transmission line, we have Zone 1 and Zone 2. So typically Zone 1 is programmed for 80% reach of the entire line impedance. So in this case, our Z1 reach is 39.4 at 72.3 degrees. And we set this value, or it's set automatically to trip on instantaneous. The second zone we have is Zone 2 reach, and this is typically set at 1.2 times the impedance of the transmission line. So in this case, we get 59.2 at 72.3 degrees ohms, and this time is set for 0.3 seconds. The third zone is the backup protection for the next transmission line, and this is set up. We use 100% of our first transmission line, which in this case is 49.3 ohms at 72.3 degrees, and we use 1.5 times the second transmission line. In this case, we don't have a second transmission line, so we're going to use 1.5 times our first transmission line. So we end up with a total of 123.3 at 72.3 degrees ohms, and this time is set for 1.5 seconds. Let us now have a look at the line side and relay side reaches. This is just referring to the primary and secondary impedance values. So in this column, we have the line side values for 100% of the transmission line impedance and the impedance reaches for zones 1, 2, and 3. In order to program the 321 relay, the impedance values must be secondary values. To determine what the relay sees, we simply divide the line side values by the PT and CT ratios. This is called our Z ratio, which in our case is 4.33. The values in the relay side column are the values which will be entered into the 321 setting sheet, which can later then be entered into the relay. So let's have a look at the 321 setting sheets. The first value to enter is the positive sequence impedance magnitude. This is the secondary value from our table. The positive sequence angle of 72.3 can be entered. We don't have any zero sequence impedance parameters for our transmission line, so we will enter a value of approximately 3 times the positive sequence value. This is a typical value that could be used. We can enable fault locating to determine the distance to the fault down the transmission line. The CT ratio is 400 and the PT ratio is 1732. Now we can look at the setting sheet and see where we enable the zones of protection that we want. So this 321 relay has 2 different characteristics. It has mode characteristic and quadrilateral characteristic. So in this case, we're going to turn on 4 mode zones, and we're going to turn off the ground mode, and we're going to turn off the quad mode. So as far as the zones in the direction they're looking, we're going to set up 3 zones to look in the forward direction and 1 zone to look in the reverse direction. And I can see from my impedance characteristic diagram below for my mode, I can see I have 3 zones looking in one direction and the 4th zone looking in the reverse direction. Let's now have a look at the settings that we enter into the relay from our calculations. So looking at our mode phase distance settings, I can see zone 1, Z1P, that is set up for 9.1. Zone 2P, so this is the zone 2 reach, set up for 13.67. Zone 3 is set up for 28.48. And zone 4, I just set this one up looking reverse backwards, 80% in the reverse direction. The angles are carried straight through when we enter them in the first parameters that we entered for the impedance of the line and the line's angle. So the 321 relay requires what is called overcurrent supervision elements or settings. So in other words, we need to have an instantaneous overcurrent pickup in order for the relay to operate in the correct zone. So there's 4 that are set up. In this case, we have 50, which is instantaneous, zone 1 pickup. In this case, we set it for 1.5 amps. Zone 2 pickup, 1.25. Zone 3 is set for 1 amps. And zone 4 is set for 1.5 amps. So now we could program our 321 relay. We set up 4 mode zones, 3 in the forward direction and 1 in the reverse. I can see that our load is purely resistive, and it is on the resistive axis at 144 ohms. We can have a look at our zone 3 reach. It reaches to 37.75 ohms in the direction of the load. So our load is well enough away from encroaching on a zone 3 and causing a nuisance trip. If we now applied a fault in location F1, we should get a zone 1 trip, and it should trip in instantaneously. We could apply a fault at F2 and it should trip in 0.3 seconds. To summarize, in this video, I went over how to determine the zone reaches for protecting a transmission line, how to calculate the relay settings, how to enter the relay settings into the 321 setting sheet so that it can be programmed. Thank you for watching.